All right. So, quick revision before we start with something. Okay. If you all remember, in the last class, I was discussing about syslog and DHCP topic. Okay. So, make use of the chat window or okay. Since we are running out of time, I'll also let you guys unmute yourself. Okay. So if you want to unmute, you can unmute, or if you want to use chat window, make use of chat window. Okay. So quickly tell me, what is the protocol number for syslog? Is it a TCP? Is it a UDP? And what is the number? So anyone remember?
UDP 514?
UDP?
514.
Yes, great. UDP 514. Okay. Okay, and if I ask the same question on DHCP, what is the protocol number for a DHCP client and DHCP server? So, what would be your answer? So, DHCP client, DHCP server. So, anyone? So, I guess this was pretty easier when compared to this. Okay, so let me check the chat.
67, I think.
Sorry.
UDP 67?
Okay, 67 for client or server?
No, I would say server.
Okay, so server is UDP 67, and what would be for client?
It'll be one up that, 68.
Okay, yes, this is a right answer. Okay, okay. So, what are the DHCP messages, or what is the DHCP process? Single word, single word.
Dora.
Yes, it's Dora. Okay,
Oh,
so
yes.
yeah,
Dora.
it's
Yeah.
discover,
Dora. Offer.
offer,
Also.
request, and
Request.
acknowledge. Okay, so
Acknowledge. Okay. Dora.
what type of communication method is this for process gonna use? So let me make it more simpler. Is it gonna be unicast? It's gonna be
We're going to broadcast.
sorry.
Broadcast.
Okay, so all of the four, or first two, or last two, or all of them?
No, it would, beginning would be discover, which would be a broadcast.
Okay.
Okay. Then it'd be unicast after that, or what?
Okay, so let me write it. So the right answer is that all the four steps runs on broadcast. Okay,
Okay.
it's a broadcast, and once the IP is assigned, then it follows the unicast.
Unicast, yeah.
Yeah, unicast communication. Okay, all right. So okay, I'm not gonna ask you the headers, which I'll give on the PDF, which is already on the web portal. Just see the flow, how the flow is. Okay. So if you remember, I was talking about the four steps. That is discover, offer, request acknowledge. Okay, so this is something from the CCNA level. Now in the CCNP and CCI, this doesn't end. So we have further more states here. And I'm going to tell you what are those the remaining ones and how are they different. So we have something called as DHCP NAC. We have something called DHCP decline. We have DHCP Inform, and the last one here is DHCP release. So I can say they are totally 4 plus 4, 8 DHCP messages. Okay, yes, these remains the same that we learned in the last class, the L2 L3 headers. The basic is this. Okay, let me just brief you what are those. So let's say I have a computer who act as a client or a user, and this is connected to an DHCP server. Okay, so as soon as you power on the client has two ways to configure the TCP IP stack. Okay, one is called as dynamic or DHCP, the other one is called as static. So static is something where you are gonna configure your own IP address, your own gateway, your own subnet mask. Dynamic is something which is automated and it's gonna send those broadcast discover message and it's gonna be sent to the DHCP server and gonna get an IP. Okay, so let's not talk about static because static is simple. It's about giving us manual IP. So let's focus on the dynamic option. That's the DHCP option. So as soon as you get your client powered on with the DHCP configuration, it's gonna trigger the discover packet. So automatically a DHCP discover packet is gonna be taken towards server. Now what server does is server is gonna send another broadcast packet which is called as offer. Let me make use of something else. Okay, it's called as offer packet. Offer is something which will contain all the parameter, the lease time, the gateway, the IP address, the subnet mask, everything. Okay, uh, client is not gonna adopt it. Client is gonna request or it's gonna asking the server to reserve. Okay, so it's gonna send one more broadcast packet which is now called as DHCP request. Okay, and it's gonna request whatever was being offered to reserve so that it can adopt it, and it's waiting for the acknowledge packet. Now the server is gonna reply back with acknowledge packet, and that's how the client gets an IP address along with other parameters, and then they are now unicast. Now there are some chances here. The chances are that I'm gonna talk about these things. Okay, so when do we get DHCP NAC? Okay, the DHCP NAC. So let's say the step number 3, that's request packet. Okay, while client sending a DHCP request packet to the server, and if the server don't answer it back, right? If a client says request and might be that particular moment of time, the server has given that IP to someone else, right? So how is server gonna respond back to client saying that sorry, I cannot listen to your request, or I have already given the IP and the parameter to someone else, right? It cannot be acknowledgement because acknowledgement is a good receipt, right? So in order to give the negative result or the bad output or the bad result, it's gonna send DHCP NAC. So you can take it in this way. ACK is a good and NAC or a non-objectional, right? So that's a bad output. So that's when server is already given the IP to someone else and that was pretty much faster to adopt it, right? So in that scenario, it's not gonna send acknowledgement, it's gonna send DHCP NAC. That's one additional DHCP state. Now what is DHCP decline? So decline is sent by client. Okay, that's when it has let's say decline is when the DHCP acknowledge was being received. The DHCP client is happy. It has taken the IP address. Unfortunately, it's gonna do some kind of gracious ARP or a ARP resolution. Okay, it's gonna send the ARP entries to make sure that IP, whatever the client is gonna adopt, is no one else having in the network. Okay, suppose it see that this IP is being taken by someone else. That is where the client is now gonna decline the message. So this is happening after all the four steps. All the four steps happened. Client gets an IP, but there is something called gracious ARP. Okay, this is again something that originate by itself. It's called as gracious ARP. Is one of the ARP form. Okay, so what does gracious ARP does is its work is to see the duplicate IP address in the network. If there is any duplicate entries, it will just try to uh, try to remove the old MAC address, or let's say basically where this gracious ARP is used is, let's say I have some device router 1 or router 2, or I have ASA firewall 1 and ASA firewall 2, and I am running them on active standby failover. Okay, failover is a concept where one device will be actively serving the traffic and second would be idle. So whenever the first device goes down, the traffic will automatically now take the secondary path. So in this scenario, what happens is your host, which are still mapped to R1, right, and which are still sending to R1, will gradually drop because R1 is not serving the traffic, it's R2, right? So what gracious ARP does is it automatically start detecting those packet and it start removing those older MAC entries, and it says don't forward the traffic towards R1 because that's down. So uh, it's trying to bind the new MAC address, the new MAC address of this, so that the traffic knows or the host know whom to forward the traffic. So that's a work of gracious ARP. Okay, so in this case, when you see two duplicate IPs, so it's your ARP which is gonna. So what is basically ARP? It's binding of MAC address to the IP address. Okay, so as soon as it sees there are the two similar IP address, it's the client is gonna decline that message. It's completely gonna decline, and it's restarting the process once again. It's once again restarting the process uh, by going to the requesting state, and it's again once again going through all this step. Okay, NAC is clear, decline is clear. Let me talk about inform now. Who is initiating this and on what condition is inform initiated? So let's assume on this particular scenario, the client was expecting for some IP address, but meanwhile, the system engineer or an user configured the pre-required configuration. So let's say someone went quickly into the box to the laptop, he installed the manual IP address or subnet, or might be gateway, which is the three required thing uh, to make this laptop up and running, right? IP address, subnet mask, and gateway. The other parameters are not actually required while doing the manual configuration. But since it was sending all this packet, it's now gonna send a DHCP inform packet to the server, and it's gonna say I have been configured manually, so I am no longer need the IP address, but give me the other parameters. What are the other parameters that it's gonna ask? It's gonna ask for the DNS information, the lease time, right? So these are the information that it's gonna ask. And how is DHCP server gonna reply back? It's gonna reply back with the acknowledgement packet. Fine. NAC is opposite of acknowledgement. Decline when you see two conflicting IP or two duplicate IPs. Inform is when that you initiated the packet, but meanwhile you were configured with the manual IPs, and now you just need the extra parameter that's required, like lease time or DNS time or the Windows server. So all are additional parameters. And the last one here is DHCP release. So this is a scenario when so let me tell you how is server actually offering the IP address, the second step. So in the second step, the server is offering all the IP address to client. Okay. When I say offer, it's gonna lease that IP. Remember the word lease. Leasing is something which is temporary. By default, let's say if it is for 24 hours, so I can say server is leasing an IP address to the client for 24 hours. Okay. As soon as you reach the half or the fifth or the exact half of this lease hour, your client has to send a DHCP release asking to extend the time. Okay. If it don't extend, the server has all the potential to take out that IP and give it to someone else. Okay. So what is client gonna do? And when is client gonna do? It's exactly half time of the lease hours. It can be anything. Lease hours can be 8 hours. It can be 24 hours. It can be anything. So whenever it reaches 4, in this case, that's a half value. Or if it reaches 12, client is gonna send DHCP release asking to extend. Okay, that's a scenario when you need extend. Now let's say it not only ask for extend, it can also remove the IP. That's the scenario. Let's say when you configure your DHCP pool, if you remember, you make use of something called exclude, right? Let's say that IP was already given to the client and you later on configure the exclude. So this changes reflect during that DHCP release message. So when you are asking for the DHCP release, it's gonna see if that IP is been excluded or it's still been permitted to be allowed, and accordingly it's gonna consider your request. Okay, so these are the 8 messages that DHCP uses. The first 4 are the prerequisite or mandatory messages, but let's say for some reason something is to be added or something is to be declined, or if something has been changed, then you need 4 additional messages to complete the whole DHCP process. Okay, so this thing I have also documented on our PDF. It's under advanced DHCP. So these are the 8 messages. I have added all the 8 messages from the starting one. Okay. Okay. What else do we have? So we have covered till this topic in the last class. Okay. Till the GNS configuration. I have few topics here, easy ones, not tough ones. Okay, so regards to the secondary IP address, which you guys must know. DHCP secondary address, and why do we use, when do we use, and how do we use. Okay, so let's say I have a DHCP server and this DHCP server is connected to the client. Let's say they are on a network 192.168.1.0/24. Okay, so you send the discovery packet and all the other respective messages happen, and finally this is gonna get 192.168.1. Let's say 10./24. Okay, so this way I can have multiple hosts on the same network, all on 192 network. Now for some reason this network is completely exhausted. I do not have any free IPs to give it to some other host. Okay, so let's say /24 has 254 free IPs and all 250 users are being occupied, so it's a exhausted, right? So I need to extend this range. I still have couple of new hosts and I don't see any network from the let's say that was a green network, so I don't have anything from the green network. So for these pink networks, what I can do is I can make use of another interface and I can configure. Now let's say if those get exhausted, might be I'll bring up more hosts and then I will make use of another interface. Now we are utilizing the interfaces. Now that's not a good idea, right? Because our interface are limited. I cannot make use of individual networks every time to extend my networks. Okay, and these networks are part of the same team, so I'm not talking about like they are in a different network. So let's say this 192.168x.x/16 is a part of your server team. Okay, so don't treat them as two different networks. They have so many available IPs, but you're every time creating them on /24, which has having 254 network. So let's say they have multiple hosts to be connected and you want to extend this. So in this scenario, what I can do is over on this interface, I will make use of the keyword secondary. Okay, so the configuration would now something look like, let's say IP DHCP Pool CCNP. I'm gonna define the network, that's 192.168.1.0/24. That's my primary. Second one, which is a pink network, I'm gonna bring in the additional network statement and I'm gonna include a keyword called as secondary. Okay, similar way I bring on the other one, the third network. I say it's 192.168.3.0/24 and it's again a secondary network. Okay, so three different pools within the parent, so three different networks within a parent pool, and I'm gonna make use of this interface, a single interface. So from the interface point of view, when I talk about interface point of view, I just need to go to this interface GI0/0. So let's say this is GI0/0 and I'm gonna configure IP address and whatever IP address that we are making use of. So 192.168.1.0 was my primary network. Now I'll make IP address 192, let me make use of a different color, 168.2.0/24 and I'm gonna write the keyword secondary, and similar way I'm gonna write the third network IP address 192.168.3.0/24 secondary. Okay, so this way what happens is only one single interface is still getting considered and we have multiple different networks of hosts connected to a single pool. Okay, so this is where we make use of the word secondary. It's mainly used when you're completely exhausted with your primary network and you're just adding up the secondary networks. Okay, and the secondary network or the third network or the fourth network, they are all part of a single team. So you would like to keep them under one single pool. Let's say if I had multiple teams. Okay, let's say if I had multiple teams, like server, IT team, security team, might be I have network automation team, right? Let's say I had 20 teams. Will you make use of all 20 interface? That's a bad design. So that's where I said we can still make use of one single interface. We can have multiple network, and on this, under this interface, I can point them. So there is a let me show you what does it say. It says that you can configure primary subnet and any number of secondary subnet. Each subnet is a range of IP address used to allocate to the client. DHCP server multiple subnet functionality enables the server address to manage additional IP address by adding the address to the secondary subnet. Okay, using the existing DHCP address pool. That's important word. You're not making use of separate address pool. You're keeping a single address pool and you're just adding up something like this. You have one single DHCP pool, you added couple of networks, and under one interface you're adding up all the other uh, default routers, or you're just trying to bind the interface with respective to the network. So something like this. So for example, this 1.2 will give or will hit to this network. Okay, if a host who is connected to this 1.1, the DHCP will take to this pool. Someone who is connected to this one 2.2, now it will hit to this network and he will get anything in that range. Similar way, if you have a different host which is on this 3.3, now that will be mapped to this range and he will get something in that range. Okay, and so on. If you have something on this interface, the DHCP discover will hit. The discover will now take it to this range 4.0, 4.1, and then finally he will get something in that range. So that's how multiple subnets under single pool with just single interface. You don't have to make use of multiple interfaces. And yes, this is a wrong configuration. Okay, so if you configure multiple pool and every pool, if you give different IPs or different networks, that's actually a wrong config. Okay, so the best configuration is make use of single pool, make use of different secondary networks and just map them instead of creating different pool or a 4 pools, because after all every pool will take its own overhead on the router, on the server. Okay, so if you have one pool, it's one instance of overhead. If you have 4 pool, there will be 4 instance of the DHCP overhead on the server. Okay, now I want to talk about the manual binding or a static binding. So as the name says, it's a manual binding or a static binding. Okay, So probably you have to give the MAC address of the client, and this will be binded directly on the DHCP server. So if I have my DHCP server, I have my client, I just need to know the MAC address of this, and I can manually bind it here. I can say that this is the MAC address of client 1 to be binded with this IP. Okay, I'm gonna give all the subnet and the default gate mask, and that's all. So that's gonna uh, work. And where is this information gonna store? It's gonna store on the NVRAM of this server. It's very simple. The configuration wise, it's simple. So what you do is you go to IP DHCP the pool CCNP. Okay, uh, just the host address, whatever the host address is, and the client identifier. Client identifier is the MAC address here. Okay, and you can just give the client name so you recognize which host are you manually binding. So you can just give that this is a host 1 or something. So this is how you are binding the MAC address with an IP address. So this IP will always remain to this client. It's not gonna be given to something else. So similar way, there is something called as DHCP static binding. So this is a scenario when you have multiple MAC address to be binded. Okay, the previous one was when you have single MAC address. So when you have multiple MAC address, it's not very easy for us to go and configure, right? So what I can do is I can create a text format. I can put all my MAC address. I can assign the IP address to each MAC address. So let's say this is the MAC address of the first client. I say the IP address binded should be this, and I mention the lease hours. Let's say it's for 24 hours, or if I'm binding it, then doesn't mean or doesn't look good for 24 hours. You should go for a longer hours like 100 hours, or you can also go for a infinite hours. Okay. So I'm talking about this from those application or server which are gonna be there in your network forever. Okay, the chances of changing the IP address is very least. For such thing, you can bind them so that IP do not go to some other users. Okay, so let's say I have different IPs. I just write the MAC address of each one of them. I'm gonna define the lease hours, and this text note or this notepad, I'm gonna point it. Okay, so what I do is I can put this text file to my flash memory of my router. Okay, via SCP protocol or SFTP or FTP or TFTP. So these are some file transport protocol. Okay, now what happens is I just go to the pool. I say IP DHCP Pool CCNP. I'm gonna say origin file. Origin file is nothing but I have to point this file. So let's say this file name was static IP over here .txt, and this file is now within this this device, this server, DHCP server. So I'm gonna point it origin file. I'm gonna say TFTP static dot txt, and I gonna say that it's a static binding. Okay, that's all. If I do this, the whole pattern will get automatically adopted, and we can confirm or we can verify with the help of show IP DHCP binding. So when I do this show command, I can see automatically all of these bindings we can see. So what is the advantage of doing static binding is all my critical servers or critical application or critical monitoring tools or my devices which are always are meant to be on that particular IP. I don't want the IP to be changed on them. I can put a static IP, and doing it one by one is painful. There can be 50 to 60 device, might be you have to reserve, right? So you can make use of this method to statically bind. It's a simplest option to do that. Okay, so I have shown you the format here. So let me first show you this one, the manual binding. So in the case of manual binding, the whatever you bind is in the NVRAM. These are the commands to manual bind it. In the case of static mapping, in the case of manual binding, you just need to do on a single hardware to a single IP. Okay, whereas automatic binding is something dynamically which happens from a pool of address. This is the text that I am talking about, the static mapping text file. You need to mention IP address, the hardware type, the lease expiry. So on the first you have the date and time when the text file was created. You have a version so that if you wanna overwrite or if you wanna include something in the future in the upcoming days, so this version is gonna help you that to show you which of the text file is the latest or the updated one. And these are the 3-4 lines which will help you to configure. It's pretty simple. Okay. Okay, so the last topic here is in the DHCP, that's boot relay, or it's called as relay agent. So this is a scenario. DHCP okay, DHCP boot relay agent. So let me tell you the normal behavior of DORA process is when the client and server are on a single network, right? So when let's say if I have a switch and I have a host, okay, and then we are connecting it to a server. So basically they are all in a single network. It can be 192, it can be 172, it can be 10 dot, it could be anything. They are on a single network, and the process is DORA process, the normal process, the discovery, offer, request, acknowledgement. All the 4 steps happens and you have an IP address. Now let's say that this DHCP server is not a server. Instead, you have something else. You have a DHCP server here, right? So these network are on 172 series and this is on 192 series, 168 series, right? So in this case, the problem with the normal scenario is, as you know, they are a broadcast packet, right? So the discovery packet which is going till here to the router is gonna drop all the broadcast packet. That's the basic definition of a router. So if I talk about router, okay, if I tell you, if a router has on one interface something called 192.168.1 dot series, the second not sub interface, the second physical interface has 172.16 network. Similar way, I have something called 192.168.20.0. So basically, they are all different networks on a router, right? So I have a broadcast, a different broadcast. I also have a different broadcast, and I have a different broadcast. So if any packet from this broadcast network hits on this, what is router gonna do? Router do not see any other network on this range, so it's not gonna forward to anyone. So the broadcast packet is just limited within this range. Okay, so you might have a switch might have a couple of end devices. So whatever you have, you're maintaining a separate broadcast here. So router is set to drop the broadcast messages, it's not gonna give it to anyone else. But if in other way, if you talk about a switch, and on a switch you have multiple hosts, okay, and if you receive something, switch is gonna broadcast to every other VLANs. The other VLANs are gonna drop it because the packet would be for a different VLAN, let's say VLAN 10 and VLAN 10, right? But it's gonna do the broadcast. That's why switch is called to be broadcasting in nature. Whereas router is not gonna broadcast, it's gonna drop it immediately. Same thing happens over here. When I am sending a DHCP discover broadcast message, my router is just dropping it. There's no way it's gonna forward it to the server. So in this scenario, on this interface, I have to make use of an additional command called as IP helper address, and I'm gonna point to this interface. Let's say the interface was 192.168.1.100. So I'm gonna say IP address 192.168.1.100. So what happens? All my discovery packet now start getting broadcasted on this. But there is one change now, that is the change on the source address. Okay, now the source will not be from this. It's not gonna look like this is originating the packet. Instead, it will look that whatever the IP is of this interface, let's say if this is the interface, so he is originating the packet and he is forwarding it to the server. And on the server side, as soon as it see that something is coming from this source, it's gonna reply back, or it's gonna give the offer, it's gonna be sent to the request packet is been sent back, and all the normal scenario. Okay, so this is a scenario when you make use of the IP helper address. And when do we use this command? It's when your server is on a different network and your clients are on a different network. Okay, so when your client and a server are on two different networks and you want to push this broadcast discovery packet towards the server, you need to make use of IP helper address. Now what is exactly this IP helper address gonna do? So this command, okay, this command is used for few of the protocols. Let's say DHCP is one such protocol where we used IP helper address. Apart from DHCP, we can also use it in the case of TFTP. We can also use it in the case of DNS. Okay, we can also use it in the case of TCAS server. Okay, AAA server. So there are some protocol when they are on a two different network, we can make use of IP helper address to achieve the reachability. Okay, so basically what this command does is it's forwarding the UDP broadcast Okay, it's forwarding the UDP broadcast. So as soon as you get that UDP broadcast, it's gonna forward it to the IP that you have mentioned. Okay, this IP. So I'm gonna say whatever UDP broadcast that you are receiving, just push it to this IP. That's the basic functionality of this IP. So let me show you this on the lab. So I have a server, I have a delay or the DHCP relay agent, and I have a computer to test. So let's say my server. Okay, let me first do a normal configuration, and I will then do uh, the the IP helper command. Okay, so to show you the basic configuration, what I'm gonna do is I'm gonna keep them all in the same network. Okay, so my switch is now just acting as a layer 2. So basically your packet is now directly hitting this server. Okay, and it will get one of its IP. So it's just normal DORA process that we did in the last class. So let me power it on. So before that, let me do the pool configurations. So let's see if I have anything for pool. Okay, so I'll just close this and restart. I already told you when you have this Alpine Linux from the GNS, you just need to untick these or uncomment these two lines, so they will start sending the discover broadcast packet. So we can see that. Okay, so if I open up my Wireshark, you can see this small tiny computer looking Alpine Linux servers are sending a lot of discover packets. So I can show you the DHCP configurations. Okay, so you can see we are keep on sending the discover packet, but I don't have any server configured at the moment. So let's configure that. Let's configure the DHCP server. So do I have anything now? Okay, so where did I get this? Okay, not an issue, I can take it out. Okay, so I go to interface first of the DHCP server. I configure the IP address 192.168.1.100 no shutdown. Now I'll go to the DHCP pool. I say IP DHCP pool CCI. I need to define the network. It's gonna be 192.168.1.1.0 I'm gonna define the default router. That's nothing but this. Okay, and let's wait for some time. So I get an DHCP IP. Okay, or I can see the Wireshark here. So on the Wireshark, I think I have already received something. Yes, I have received something. Okay, it was a normal DORA process on a single network when the server and client are on a single network. Okay, and how do I check the IP address? If I do if config, I can see there is an IP now. So it's a 1.1. If I ping my gateway, so it's reachable. So what I'm gonna do now is this server, I'm gonna make it L3 now. L3 layer. L3 layer in the sense it will start working on a routing now, or on a IP based. Earlier at current it's on a L2. It's on a single VLAN 1. But now let's change that VLAN 1 behavior and make it as L3. So to show you that, now I'm gonna consider this PC. So this PC will, this of course will be on DHCP. This interface will be on this IP, and this network will be on 192. So basically this, now look, this start behaving like a L3 box, and the client and the server are now falling under two different networks. So in such scenarios, I'm gonna show you what is an IP helper. How is IP helper gonna help us? Okay. So if I just clear this, I go back to this. Okay. So let me see if I have DHCP configured here. Okay, sorry, not that instance, it's this. Yeah, they are on a DHCP. I'll open up this. So let me see if I have some IP now. Okay, so it's already taking something. So what I just do is I'll just power it off so that it stop taking. Okay, and also I will see if I have some binding. So how do I see? Show IP DHCP bindings. So I can see something, but yes, I can also clear them. Clear IP DHCP binding star. It will clear all the bindings. Okay, so I don't have any bindings. And let me make this look like a layer 3 in a different networks. So on the one side, the side which is facing to the client, let me configure first. So I say it's Giga Ethernet 0/2. IP address is 172.16.23.100.255.255.255.0. Okay. So before that, I need to turn off the layer 2 capabilities. Okay. So no switch port will turn off the layer 2, and then I need to add my IP address and make use of no shutdown command. Now let's go to the other interface on the right hand side, which is connecting to the DHCP server. So let me make that interface as 192, 168, 1.99.255. Okay, so before that, no switch port. Otherwise, it will not let me to configure. IP address 192.168. 1.99.255.255.255. 0, no shutdown. Okay, let me once quickly see. So when I bring it up, they will not get anything. Okay, so it's sending something, but it failed. Okay, so you can see they are getting failed. What about from the Wiresha point of view? Okay, I can bring up Wireshark. So let me close the other one, the normal or the easy configuration. So let me take out that. Let me show the capture now for this. You will see the discover packets are getting generated. Okay, you are sending lot of discover packet, but the discover packet is not getting forwarded. Okay, it's just gonna be limited within this. And since they are in a two different network, what is a layer 3 gonna do? It's gonna drop the broadcast message. So your broadcast discover message is no longer gonna go to this, right? So what I do first is, first I'll bring something on this. Okay, I need a DHCP pool on this network. So let's say IP. So let me try to show you the. Okay, or I'll do a new pool. So let's say DHCP pool, DHCP relay, and I'm gonna create a network 172.116.2.3.0.255.255.255.0. I'm gonna configure default router 192.168.1.100. Okay, so nothing so far done. It's still on a discover packet. The main command is something which I'm gonna configure now. Okay, so I am going to this interface, it's interface gi0/2, and I'm gonna say IP helper address, and I'm gonna point towards this. Okay, so basically I have to point here, so that's gonna be 192.168, it's 1.100. Okay, if you see now, if you just take the Wiresha capture before doing helper address, let's see what we get. Okay, so this is something for my previous case. As of now, there is no uh, nothing being done, so I can also show it over here. So if I go to my host, so there is no IP. Okay, there is no IP address because this particular line has to be configured. So let me put this command, and what happens is it will start forwarding all the UDP messages. Okay, so where am I? Do show run interface gi0/2. Okay, what is the pool that I configured? Did I configure 23? Do show run. Let me take this out. That's not no longer required. Do show. So I have 23 172.16.23. I have 1.100. On this side I have 23. What about 0/0? Okay, okay, let me quickly see what is not working here. Okay, so this is one single command which will forward the packet. Okay, so I'm just wondering why I don't see any forwarding. 23.100. 23. So just let me close this Wireshark once. Let me see if I get any DHCP packet. So this is basically from the previous lab, not from now. No, DNS server and other things are not required. So let me try giving a default gateway from DHCP server. But the problem is not about the default gateway, because I must get the discover packet. So this Wireshark might be not getting updated. So I'll give some static IP 192.168.1.99. Okay, see, now it started working. So the thing is, since we are making use of the router will not know the return path. Okay, so it's sending the discovery packet only unidirectionally, okay, from client to server. But for the return traffic, you must point, or you must give an static IP saying that whatever you get or whatever you're sending, send it across to this interface, that is 192.168.1.99. Okay, and then you're just sending all your messages, all your DHCP messages to the client. So the main catch here is that IP address. Okay, so all your discover packet which is gonna get discarded, with the help of helper message, it's now getting forwarded onto this interface. Okay, since I'm making use of a router, a layer 3 device, and a layer 3 device needs to know how shall I return back the traffic, because it doesn't know anyway, because since they are on a two different network. So I must make a provision to send the return traffic, or my offer packet. So I give an additional comment or an additional default gateway. Okay, so I can make use of the command ip route 0.0.0.0.0.0, and I'll point out to this interface 192.168.1.99. So all my messages go across here. Since this is since this is a layer 3 now, it's gonna send that. Okay, now this is not gonna be broadcast, it's gonna be unicast message. Okay, it's one-to-one message, and that message will be sent to the client, and client is once again sending the broadcast message. The broadcast message will, with the help of IP address, be taken to this, and then they form kind of a server client model. Okay, so the helper message is trying to forward the exact broadcast message. If you see the bindings now, show IP DHCP bindings, so you will see one of the IP from this range has been allotted, 172.16.23. That's this one, a different network. and intermediately you are on a different network, 192 network. So in this scenario, when you have when the server and the client are in two different network, you make use of the IP helper headers. It's a special command, and this special command can be used in different protocols also. Okay, not just in DHCP. You have multiple protocol where IP address is being used. So basically it is used to forward the UDP broadcast on the it's used to broadcast the UDP packets. So what does it says? It's used when they are used in two different networks. So what is helper, or what is it going to do? It will append its own IP address. Okay. So let's see what does it say. So what happens is, you will see now the packet are not exactly originating from 0, right? So if you see here, but the default thing, or the default working nature is that they originate from 0.0, right? But in the case of IP address, that's my second Wireshark, you will see packet were originating from 32.100. 32.100 is this interface. That is your IP DHCP, or the IP helper address. So that's how IP helper is gonna work. Okay. So instead of 0.0.0, it's now including its own IP address as a source and forwarding it. So you can see it over here. So it's adding its own source address and it's sending to the DHCP server. Okay. It will append its own IP address to the source IP address, and then it will push it to the DHCP server. How is the return traffic? How is the server gonna respond? It's gonna be unicast packet, that is one-to-one packet. So that's all about for the DHCP. These are the 8 messages. This is delay. This is a relay agent, the static DHCP binding, the manual DHCP binding, the secondary subnets, the basic DHCP configuration when they are on a single subnet, the basic 4 messages, the first 4 messages. This is packet level detail of the DHCP operation. It's also called as DHCP operations. Okay, the L3 packet and L2 packet. This is very important from the interview point of view, because they can ask you to write the L2 and L3 headers of a DHCP packet. And yeah, these are some key points. So that ends the DHCP topic. So yes, let me know if you guys have any doubts with respective to DHCP. So I'm just going through the chat window. Yeah, the default gateway really helped. Okay, the default gateway is used because we are making use of an router. Okay, and router must know the return traffic. So what is happening is, your router is getting all the discover packet, but it's not sending it back, and you need to make the way, or you need to clear the way by configuring the default gateway. If you receive something, send it back to that switch, and the switch will then take it to the client. So any doubt here on a DHCP? Alright guys, so I take it as good from everyone, and let's meet up in the next class. So I'll upload the 2 classes now. Okay. and I'll post you once it's done. So good night, everyone. Let's meet up in the next class. Okay, so you say show. Can you show uh, how to how? I didn't get your question. Are you asking me to do the show run? So is your question about show? How do we see the show run, or you wanna check something? Okay, so you wanna clear the DHCP binding. So you can make use of clear IP DHCP binding. You can give a static IP address, or if you wanna clear everything, you can clear everything. If you have your DHCP on a VRF, like multiple VRFs, then you can mention VRF. Okay, and then you can make use of the word, let's say customer A, and then you can clear any specific binding for that customer, or you can clear all that for that particular customer VRF. So is that fine? So all good, all good, all fine. Okay. All right, guys. So let's meet up in the next class. Have a nice day. See you soon. Take care.